Free fall is a concept of physics that says different objects, regardless of mass, will fall at the same rate. This sounds rather far-fetched, but in theory, if two objects, a feather and a ball, where a ball has more mass than a feather, were to be released from the same height above ground, the following would occur. The force of gravity, weight, would be greater on the heavier object, the ball, than on the lighter object. This is because weight is proportional to object's mass. Gravity is equal to weight is equal to the mass multiplied by the gravitational acceleration. On the other hand, the acceleration is proportional to the force. This means that the ball will accelerate twice as slowly as the lighter object, given the same force. F is equal to ma. A is equal to F divided by m for object 1. A is equal to a half F divided by m for object 2. So if you think about it, the two competing factors cancel each other out. In practice, the above is only true if air resistance is neglected. These kinds of experiments, where there is no air resistance, can only be performed in a vacuum chamber. A vacuum chamber is a rigid enclosure from which air and other gases are removed by a vacuum pump. This results in a low-pressure environment within the chamber, commonly referred to as a vacuum. Kinematic equations. You're probably asking yourself, why bother studying free falls? Well, a vacuum environment allows researchers to conduct physical experiments or to test mechanical devices which must operate in outer space. Also, the study of free fall is to develop models that serve to describe and explain the motion of real-world objects. Although in practice, falling objects may not be in free fall kinematic equation can be used to predict the motion of real-world objects.
So you want to memorize the kinematic equations. I'm going to use the Walker textbook's format for the kinematic equations. Kinematic equations means that the acceleration is constant. Let's put that down here. Acceleration is constant. When I say kinematic equations, I mean the acceleration is constant, and I mean we're not concerned about why stuff is moving. This tells us how stuff moves, not why, which would have to do with forces and well, generally just forces and torques, but the kinematic equations are telling us simply how things are moving. So I'll write the 4 kinematic equations down, and you want to memorize these suckers, so I'll name them for you also. We'll talk a little bit about how they work. This first one is the definition of acceleration. It says that your speed at any given time, your velocity, is equal to your starting velocity plus how much you've been accelerating multiplied by how long time's been going on. So if we rearrange this just a little bit, we'll see why it's the definition of acceleration. Definition of acceleration. Definition of acceleration because check this out. We know that if we can subtract v naught from both sides, we get v minus v naught is equal to acceleration times time. Now I'm going to divide delta t into both sides, and we'll have v minus v naught divided by time is equal to acceleration. And I'm going to go ahead and put a triple line right here because this is what acceleration means. And I can explain it to you by going one line deeper. This is v minus v naught, which is change in velocity, and that should of course be change in time. That's what acceleration means. It is the slope of the velocity versus time graph. So that's what an acceleration is. So when you see this equation, think of the definition of acceleration, or you can think of it in this form, but the books usually present it like this because it's more useful for finding how fast you're going in that form. The next equation we're going to address is what I call the definition of average velocity. It says delta x is equal to 1/2 your starting velocity plus your velocity right now times how long you've been going. The reason I call this the definition of average velocity is well, we'll need a little bit more space to do that. I'm going to pull this over a little bit and we'll go back in a moment. The definition of average velocity, this is the initial plus the final velocities added together, and if I take the initial and the final and I add them up and divide by 2, that's a way to take the average. The reason we can assume that the average velocity is directly in between the initial and the final is because the velocity must be changing steadily. That's the statement right here that the acceleration is constant. This equation is not valid when the acceleration is not constant. So we have to use it only when the acceleration is constant. So we'll take this equation right here, and I'm going to argue that if we divide by delta t on both sides, we'll get it to say delta x divided by delta t is equal to 1/2 the initial velocity plus the final velocity. And that's what average velocity is. So that's why we can say this is the definition of v average. You have to be very careful with that. The next kinematic equation that we'll address is delta x is equal to v naught times t. This says that how far you've gone is how fast you were going times time. And of course, if there's no acceleration at all, this is how far you've gone, how fast you're going times how long you've been going. But if there's acceleration, we have to add one more term, that's plus 1/2 acceleration times time squared. This equation is so useful and so ubiquitous, I call it the classic. And it comes from calculus. This 1/2 right here, the square right here, you'll see this is a beautiful calculus form that comes up all the time. And the final kinematic equation that you want to have memorized is v square is equal to v naught square plus some stuff. 2 times acceleration times how far you've gone. And I call this a tale of 2 squares. Good. Ask me some questions in the comments.